An absolute value inequality is one where the x variable is located inside the absolute value bars. And in order to solve an inequality like this, the first thing that we want to do is get those absolute value bars by themselves. We can do that in this example here by adding 4 to both sides. These 4's cancel out, and I'm left with the absolute value of 1 minus 2x by itself on the left-hand side is less than 3. Now, once we have our absolute value bars isolated, we do want to make sure that there's a positive constant on the other side of the inequality. This number does need to be a positive 3. If we had a negative quantity over there, we would do something different, and that'll be explained in a different video. Once our absolute value bars are isolated, if we have a less than symbol, we're going to set up a compound inequality that we can solve. And that compound inequality is going to be such that what is inside the absolute value bars is going to be sandwiched in between the positive 3 and the negative 3. And let's think about why that is for just a quick moment. In order to have an absolute value that is less than 3, the 1 minus 2x that's inside the absolute value bars has to fall somewhere in between the negative 3 and the positive 3. Let's say the value of 1 minus 2x turns out to be positive 2. Then all of this would be positive 2, and its absolute value is less than 3. If 1 minus 2x inside the absolute value bars turned out to be negative 2, then 1 minus 2 here inside the absolute value bars would be negative 2, and its absolute value is also less than 3. So when our absolute value bars are isolated and we are less than some positive constant, we're going to set up a compound inequality that describes where the inside of the absolute value bars must fall on a number line in order to satisfy the criteria that it's less than 3. And so this is our inequality. Now we need to solve this compound inequality, and we do so by subtracting 1 from all 3 of those places. Anything that we do to isolate the variable in the center has to be done to all 3 spots. So this is going to be negative 4 less than, the 1's cancel, and we have negative 2x inside here and then 2 on the outside. We're continuing to solve for x in the center, so we'll need to divide by negative 2. We also need to do that to all 3 of those locations. Now, anytime we divide by a negative, we're going to need to reverse the direction of the signs. And actually, that happens anytime we multiply or divide by a negative. Over here on the left, we have negative 4 divided by negative 2 is positive 2. We need to reverse all the directions of each of those signs. The 2's cancel out in the center, and we have just positive x, reversing the direction of this sign as well, and we then have negative 1 over here. Now it's time to express our answer in both interval notation and in set builder notation. In order to do that, I'm going to graph my solution set on the number line just to make sure that it's nice and clear where we start and stop. And notice that the negative 1 is the smaller value. I'm going to place that to the left on the number line, and we're looking for all the values that are in between negative 1 and positive 2. So our solution set is in here, and the interval notation is going to look very similar to how the set graphs on the number line. We'll start with the smallest element in the solution set, which is negative 1, and move to the largest element in the solution set, which is positive 2, and then we either have brackets or parens, depending on whether or not we're including those endpoints. In this case, we use parentheses because neither endpoint is included. And for set builder notation, we basically have a template where we're looking at the set of all x's such that, and then some criteria needs to be met, and then we close the set. Now into this criteria field, we basically are going to pull in this compound inequality that is our solution set. However, the one thing that I'm going to change is to make the smaller number on the left-hand side. So I'm basically going to just flip this entire inequality to say negative 1 is less than x is less than 2. And now we've squared it up so that it is the smaller number on the left and the larger number on the right. So this is the solution to the inequality in interval notation and in set builder notation. Let's do one more example. We have an absolute value inequality again. Our first step is to isolate the absolute value bars. We do that by adding 5 to both sides. Now we have the absolute value of negative w plus 3 isolated on the left, and we are greater than or equal to positive 7 now. Again, we want to make sure that we have a positive constant once those absolute value bars are isolated on one side. Now we saw from above that when we have a greater than symbol, when our absolute value bars are isolated greater than that positive constant, we're going to set up 2 inequalities and solve each of them individually. Let's look at a number line to determine what those two inequalities would be. So where would negative w plus 3 have to fall on the number line so that its absolute value is greater than 7? So 7 and negative 7 can be considered our points of interest. So considering negative w plus 3 inside these absolute value bars, that quantity would have to fall outside here. We would need negative w plus 3 to be something larger than 7, right? If we had positive 8 inside here, its absolute value would be greater than or equal to 7. Or this negative w plus 3 could fall out here. I could have negative 8 inside the absolute value bars, and its absolute value would also be greater than 7. So we basically need to turn this into two inequalities. One where negative w plus 3 could fall out here. So we say negative w plus 3 could be greater than or equal to this point of interest, which was the 7. Or the negative w plus 3 inside the absolute value bars could turn out to be down in this region, which is less than or equal to negative 7, that negative point of interest. Essentially, negative w plus 3 could be up here or down here. And now we have two inequalities that we can solve individually, so we'll subtract 3 from both sides here, and we get negative w is greater than or equal to 4. When we divide both sides by a negative quantity, again, that's going to reverse the direction of the inequality, and we have less than or equal to negative 4. To solve the second inequality, we're going to subtract 3 from both sides to get negative w is less than or equal to negative 10. And when we divide both sides by negative 1 to solve for w, again, we'll have to reverse the direction of the inequality and get positive 10 like this. So our w values could be less than or equal to negative 4 or greater than or equal to positive 10. Now we need to write the solution in interval notation and set builder notation. In order to do that, I prefer to graph the solution set on a number line. It helps me to get clear on what that interval notation is going to look like. Our points of interest now are the negative 4 and the positive 10 that are the boundary points essentially for our solution set. So the values of w that solve this inequality are going to be either less than or equal to the negative 4, which is down here, or greater than or equal to the positive 10, which is up here. With this graph, we can more easily see what the interval notation should look like. The smallest value in the solution set is down here at negative infinity. So that's where we begin with the interval notation. We come all the way up from negative infinity to the negative 4. We include negative 4 in the solution set because w is less than or equal to negative 4, so we get a bracket there. Now if we have a gap in the center of our solution set on the number line, that's going to require us to use the union symbol right here in order to basically glue these two intervals together. So from negative infinity to negative 4, union, positive 10 to positive infinity, the infinities always get parentheses around them because you're not able to include infinity. And again, in set builder notation, we essentially use the same template. Now we're talking about w's though, so we'll say the set of all w's such that some criteria holds, and then we close the set. And in this criteria field, we essentially use the inequality version of our solution. So we would say w is less than or equal to negative 4, or w is greater than or equal to 10. And this is the solution to our inequality in set builder and interval notation.